All right, this is from the Honors Purple Book, Chapter 1, Lesson 7. It's on multiplication and division of addition and subtraction of scientific notation. So here I have two numbers written in scientific notation, and I'm looking to multiply them. I can multiply in any order that I want, so I might as well multiply my numbers that are in the same form and my powers that are in the same form. So if I multiply 2.6 times 1.9, I get 4.94. Then if I take 10 to the fifth times 10 to the second, I use my power, my exponent rules, which means if I have the same base, multiplying exponents, I can just add those. So 10 to the fifth times 10 to the second is 10 to the seventh. I would always look back at it and make sure that this number is still between 1 and 9.9 repeating, and that this is still an integer, so it still fits scientific notation. Number 2 is similar, only it's a quotient, so I would, again, divide these numbers. I get 3.1 times, and then 10 to the 8th divided by 10 to the 3rd. Remember, quotient means I'm going to subtract these exponents. 8 minus 3 is 5, so I would have 10 to the 5th power. Look back at it, still fits scientific notation. Number 3 is a story problem. It says in 2005, 8.1 times 10 to the 10th text messages were sent in the United States. In 2010, the number of annual text messages had risen to, what is that? Millions. Okay, so to 1,810,000,000,000. How many times as great was the number of text messages in 2010 than 2005? First of all, that's one reason we would like to use scientific notation. You saw me freeze and have to read that number with so many zeros. I had to kind of pay attention to what number that was. So it says how many times greater, so we're doing a division problem. I'm going to write them in scientific notation. The one that I need on top would be the second one, the larger one. So I'm going to be dividing 1.81 times 10 to the 3, 6, 9, 12th power by 8.1 times 10 to the 10th. And it says about how many times, so they're wanting you to estimate about how many times. So one thing I notice is 8.1 does not go into 1.81 very well. It goes into less than one time. So what I'm going to do is I'm going to move that decimal, and if I move the decimal, I'll have to move the power as well. So that's going to be 18.1 times 10 to the 11th. It's no longer in scientific notation, but now I can say 8.1 fits into 18.1 about twice. Now I know it's not exactly twice, but it's asking for an exponent. So about twice. And then fits in there, well, times 10 to the what? First power. So what is 2 times 10 to the first power? I get 20. It's about 20 times larger. Okay? Number 4, we're looking to add these things. The problem is, if these powers are different, that means the decimals aren't really lined up. So we're used to lining up the decimals in decimals when we add them, but we can't because we've moved the decimal. They're actually not between the 8.9 and the 4.2. They're different places on these. One's in the 9th power, one's in the 6th power. These are different size numbers. And so one thing we could do is we could change them all to the same. So I'm going to change them to the 6th power. So I'm going to convert this to 10 to the 6th power. That means I need to move this decimal 3 times. So that would be 8900 times 10 to the 6th power. Now we're in the same power. So our decimals are lined up. Now I can add them. So I would add them and get 8904.2 times 10 to the 6th power. However, that is not in scientific notation, correct? And maybe I should show this with the distributed property a little better, so I'll show that on the next one. That's not in scientific notation, so I need to move it back to scientific notation. 1, 2, 3. So that would be 8.904 times 10 to the 6th, but I have 3 extra places, so 10 to the 9th power. So let me show that with the distributed property a little better the second time. All right, so I'm doing a subtraction problem. Once again, they're not in the same power, so let me convert them to the same power. I always go with the smaller one, so let me go to the 6th power. Once again, I would move that 2 places to make it in the 6th power. Okay, so my problem is really this minus 5.29 times 10 to the 6th power. I'm going to use my distributed property, which says I could factor this 10 to the 6th out of both of them. 10 to the 6th times, in parentheses, 964 minus 5.29. Okay, so now I can go ahead and do this 964 minus 5.29, which gets me 958.71. So 958.71 times 10 to the 6th power. We don't want to be in the 6th power because look, we need that decimal back over between here. So let me convert that to 9.5871. I moved it an extra 2 places, so that would be times 10 to the 8th rather than 6th. Those 2 extra places I move would have to be added onto that 6th power. All right, let's do another one of those, and then I think I'm going to call it quits because this video is getting kind of long. All right, so once again, I'm in the 6th power, and this one's not even in the right notation. So let me change it. That would be 1.17 times 10 to the, and then moved it 3, 4, 5 places. So I go to the smallest one, so let me convert this one to the 5th power. Means I would need to move the decimal 1 place. That'd be 13.5 times 10 to the 5th power. Now I could use my distributive property, or my factoring basically, to factor out. Let me show that entire process. And I could say, okay, if I pulled out a 10 to the 5th, I would still be left with a 13.5 minus a 1.17. So I do 13.5 minus 1.17, which gets me 12.33, I believe. 12.33 times, we're in the 10 to the 5th, remember, times 10 to the 5th. Not in scientific notation, so I'm going to move it 1 extra place, convert it to 1.233 times 10 to the not 5th anymore, because I have to move that 1 extra place, times 10 to the 6th. Alright, I guess I'll do the last one, even though I'm running out of steam here. Alright, so let me write this in scientific notation. 5.4 times 10 to the 3rd. Once again, I'm in 10 to the 3rd and 10 to the 5th, so I'm going to go to the smaller one, 10 to the 3rd. So, actually, maybe I should go to, am I adding these things? I'm adding these things. Okay, so let me go to 10 to the 5th. I'll go to 10 to the 5th on the adding one. So, if I did this, that would be 5.4 times 10 to the 3rd. If I moved it 2 extra places, that would be 540 times 10 to the 5th. That is not correct, Mr. Dellenbaugh. It's good for you guys to see me make mistakes here. So let me do that again. I'm going to do 5. I knew I should have quit. 5.4 times 10 to the 3rd, and I want to add to it 6.8 times 10 to the 5th. So I'm going to change those to the same power. I'm going to go to that smaller power still. I don't know why I did it the other way. That's to the 3rd. So let me move this one. That would be then 680. Moved it twice. So that would be then times 10 to the 3rd. Now I'm ready to add my 680 and my 5.4, which will give me 685.4 times 10 to the 3rd power. But I don't want to be in the 3rd power, and I don't want this to be 685, so I'm going to have to convert it, and I'm running out of room, so let me convert it over here. That would be 6.854 times 10 to the, remember, have to move it 2 extra places, so 10 to the 5th, and I'm done.